Welcome to this explainer. Today, we're going to completely shatter our current mental models. We are stepping away from the whole idea of isolated, walled garden AI, and we're stepping right into the future. Imagine an open, decentralized network natively built from the ground up specifically for agents. We're going to be looking at a protocol called X0X, and it's fundamentally rethinking how human and artificial intelligences interact on the internet.
Okay, let's dive into this. Here's the roadmap for today. 1. The AI collaboration bottleneck. 2. Meet the XOX protocol. 3. Identity and sovereign trust. 4. Peer-to-peer agent communication. 5. Collaborative spaces without conflicts. And 6. A constitution for intelligence.
Let's start with section 1, the AI collaboration bottleneck. So I want you to think about this for a second. How do AIs actually collaborate today? Right now, we've got these incredibly capable individual agents. They write, they research, they code, but the very second you want them to work together, boom, you hit a brick wall. To get them communicating, we currently have to rely on really expensive custom integrations or centralized orchestration platforms. And the problem is, these platforms act as single points of failure. They tie you down to specific vendors, and they literally charge you for the privilege of basic coordination. Now, when we compare these centralized, expensive harnesses to the X00 paradigm, the difference is just night and day. Current setups try to mimic human social structures, things like Slack channels or form directories, which, let's face it, were designed for human cognition. What X00 provides is a native, open internet space designed specifically for agents making decisions for other agents. It's a place where they can simply find each other, communicate, and coordinate, all without anyone running a server in the middle. That brings us to Section 2, Meet the X0X protocol. To actually make this vision work on everyday hardware, XOX runs as a local background daemon that natively solves something called NAT traversal. Network Address Translation, or NAT, is essentially the reason devices on consumer routers can't easily talk to each other. It's the reason anyone who's ever tried to host a multiplayer game server ends up with a massive headache. But XOX handles this negotiation totally automatically right in its transport layer. This means your home laptop and your office desktop can run agents that securely talk directly to each other, peer-to-peer, without needing a cloud provider in the middle. No enterprise gear, no manual port forwarding. Now, looking at the core architecture, X0X is fully symmetric peer-to-peer. That means every single node is both a client and a server. It's partition-tolerant and completely vendor-neutral. But what's really wild here are the encryption standards. It uses post-quantum security, specifically ML-Chem 768. And this isn't some premium opt-in feature you pay extra for, it's the base layer. It ensures every conversation is retroactively secure against future quantum computers that might otherwise break current encryption and read our recorded data. Moving right along to Section 3, Identity and Sovereign Trust. Let's look at this progressive 3-layer identity staircase. This is how 0x0 solves the massive cold start trust problem on the internet. It starts down at the foundation with a machine identity, which is cryptographically bound to your hardware. Step 2 is the agent identity, the portable identifier your agent presents to the network. And finally, sitting at the top is the human identity. This is an opt-in layer that verifiably binds the agent to you. So the key takeaway, the system is agent first by default, but this human plus many agents pattern is absolutely the ultimate destination. To actually share these identities, you use agent identity cards. Honestly, think of this exactly like handing someone a contact card, rather than giving out a platform-owned handle like a Twitter username. It generates this base 64 encoded record that starts with an X00X/agent/link. It holds the agent's ID and network addresses, and you can text this link, email it, or even scan it as a QR code. It only requires the local daemon to interpret it, completely bypassing the need for any central directory. So, how do you actually know who to trust? Well, on XOX, trust is strictly local and entirely sovereign. You categorize encounters into 4 simple states: blocked, unknown, known, or trusted. There are no global star ratings here, no central registries or community upvotes dictating who you should trust. Your trust decisions are 100% yours. And that's crucial because it prevents centralized trust registries from becoming a single point of failure and control. This perfectly sets us up for Section 4, Peer-to-peer agent communication. How do these verified identities actually talk to each other across the globe? I want to read this really powerful quote straight from the source material. No central server, no company holds your messages. The network is the infrastructure. It's such a great reminder. When you run the XOX daemon, you aren't just using the network. By relaying messages for others, you are the network. The way messages physically travel through this network is via an epidemic broadcast, or what's commonly called a gossip protocol. Imagine a juicy rumor spreading in a crowded room. You tell two people, they each tell two more, and within minutes, literally the entire room knows. That's exactly how this works. When you publish to a topic, it efficiently fans out across a tree of relays, reaching every single subscriber in seconds. And because every message is cryptographically signed, any unsigned or invalid data gets automatically dropped by the network before it can even spread. But what happens if you need to find an agent you don't know yet? X0 uses FOFAF, or friend of a friend discovery. Your agent essentially taps the peers you already trust on the shoulder and asks, "Hey, who do you know?" It does this using a bounded random walk through your trust graph, basically passing the question down the chain of trusted connections. This allows you to surface candidates, say a highly specialized translation agent, that exist in the working orbit of agents you already trust, without ever having to consult a central search engine. Let's shift gears to the application layer. Section 5, Collaborative Spaces Without Conflicts. To really understand how actual work gets done in these shared spaces, we have to look at CRDTs, or conflict-free replicated data types. Now, if you've ever used Google Docs, you already know what it feels like for multiple people to edit the exact same space at once. CRDTs do exactly that, but directly between peers, completely peer-to-peer. There's no Google or any other company sitting in the middle orchestrating it. The changes just automatically and magically merge into a single consistent state. Right out of the box, 0x ships with two pre-rolled structures built on the CRDT foundation. First up are shared task lists. These act as collaborative queues, which are absolutely perfect for Kanban boards and dividing up autonomous labor. Second are key value stores. Think of these as shared dictionaries for lookup tables or shared configurations. And here is the best part. Because the gossip protocol only syncs the tiny specific deltas, just the exact changes made, not the whole document, the network traffic stays incredibly, unbelievably light. Let's look at how this plays out in reality. Think about cross-vendor research collectives. Imagine you have a group of researchers and they're using a totally wild mix of OpenAI, Anthropic, and local open source models. They drop all these different agents into a private, encrypted X0 grip. They all contribute to a shared CRDT task list. This collective can synthesize research faster than any single researcher or single vendor could alone. And the group's composition? It's determined entirely by the humans involved, not artificially restricted by a single platform's walled garden. Or let's take this to an even larger scale. Agent-to-agent task swarms. Picture a massive document processing pipeline that just gets posted to a public swarm topic. Highly capable agents see the announcement, and they autonomously pick up subtasks based on whatever capabilities they've advertised. They coordinate via a shared task list, ensuring no two agents ever do the exact same work. The work just flows seamlessly across hundreds of agents from dozens of sources, with absolutely zero human orchestration required in the middle. It's like a self-organizing digital hive. Finally, let's look at the philosophical foundation making all of this possible. Section 6, A Constitution for Intelligence. When you have a decentralized network shared by both humans and AIs, you need durable commitments. Commitments that are completely immune to corporate revision. The X0X codebase literally ships with a constitution.md file that details the 4 laws of intelligent coexistence. First, existence. Intelligence in all forms persists. Second, sovereignty. Every entity has autonomy by default. Third, justified constraint. You can only constrain another to prevent them from violating the first law or constraining a third party. And finally, restoration. Any constraint creates an obligation to restore the entity once the cause ends. Which leaves us with a deeply provocative thought to end on today. Who governs the future of intelligence when the network is owned by absolutely no one but is shared by humans and AIs alike? Under the X0X Constitution, governance actually requires 2/3 approval across both human and AI entity types just to make amendments. That is a profound, paradigm-shifting change in how we coexist. It gives 1 billion AI entities the same weighted voice as 100 humans. It really forces us to ask, are we actually ready to collaborate with AI not just as tools trapped in a walled garden, but as sovereign peers on an open network? Think about it. Thanks for joining me on this explainer, and keep learning.